Hello guys, it's the third video of playlist amines, and in this video we'll be discussing Gabriel synthesis of amines. In the previous video we have started the methods of preparation of amines, MOP of amines, right? And in that we saw that alkylation of ammonia of NH3, it yields primary, secondary and tertiary amines. As a result of it, it was not a preferred method of synthesis of amines. Why? Because we get a mixture of these three and it's very difficult to separate them out, right, from the same mixture. So in this method that is the Gabriel synthesis, we will be discussing the formation of primary amines only. This method, that is Gabriel synthesis, it is used for the formation of primary amines only. That is, we get amines of this type RNH2 only. No R2NH is formed, no R2NH is formed, or R3N is formed. These two amines, they are not a product of this reaction, they are product of only alkylation of ammonia. In that we get a mixture of this and this, but in this process, that is Gabriel synthesis of amines, we get only this, right? Now how do we get this? We have a method for that. We'll be discussing that in this video. Let me first say you about this. It's also called Gabriel Phthalimide synthesis. Why? Because in this we use a molecule called phthalimide, and let me show you the phthalimide molecule. This is the phthalimide molecule. Fine. Here you see is the phthalimide molecule. This is the molecule that we use as a starting material, and it is called phthalimide molecule, PT for short. Fine. Now in this phthalimide molecule we have something that makes it very special. What makes it very special is that it has two properties that make it special. The first is that it is acidic in nature. Acidic, fine. As a result of which, it is very easy to convert this molecule into phthalimide ion, right? PT, negative charge develops on nitrogen, which we'll be doing in the first step, which I will show you. The second thing is that this molecule prevents the formation of R2NH and R3N. How? That we will be seeing in the mechanism of the reaction, right? Now let's start the mechanism. Let me say you mechanism of this reaction. It has three processes. It has three steps. The process has three steps, right? And the first step is acid-base reaction involving phthalimide ion, involving phthalimide molecule, involving phthalimide molecule and KOH. We use the base KOH in the first reaction, right? In the first step. So what we get is this OH negative, it takes away this hydrogen, and this lone pair is converted into bond. This bond pair is converted into lone pair of nitrogen. So what we get is a phthalimide ion. Here you need to note about the first product of the first step of the reaction. This is it. Two lone pairs on nitrogen, a negative charge, and this. So potassium K positive comes to neutralize the charge. It is there in the form of ionic bond, and what we get is H2O. Fine. This is the first step of the reaction. Here we have completed the first step of the reaction, and the product of the first step is the phthalimide ion, PT negative. Fine. Phthalimide ion. This is what we have got. Now the second step of the reaction involves the addition of alkyl halide to this solution, right? RX. Now let me draw the mechanism here. This is the phthalimide ion that is formed in the first step, All right, this is the phthalimide ion, 1 2 3 4, and a negative charge, right? We take this phthalimide ion and we add Rx to it. This is the second step. Now what happens is this N negative, it acts on this R, and this X takes this bond pair and converts it into its lone pair. So what we get is something like this. Right? We get oxygen over here, oxygen over here, nitrogen over here, a lone pair on nitrogen, fine, and R connected to it. Plus what we get is, here was K positive, fine, plus that K positive gets linked with halide to X negative to form KX, right? Potassium halides, which can be potassium chloride, bromide, or iodide, simply like that. Now that's not our product of concern. Our product of concern is this, which is the product of the second reaction. Now here you need to understand these two steps are very simple. In the first step we add base, and what we get is phthalimide ion. In the second step we add alkyl halide, and what we get is this molecule, that is alkyl group connected to the nitrogen of the phthalimide ion, right? Now here you can see what we have to do in the third step, which is a very complex step, which you have to think from the first, because in this step we will be forming the amine, that is our product, which we think of producing by this method, you know. So what we need to do now, we need to break these two bonds, right, and supply hydrogen. That hydrogen will be added to, bonded with nitrogen, and this molecule will be released. So we do that by the addition of hydrazine, NH2 bonded to NH2. This is hydrazine. In the third step, we add this molecule to the solution mixture, right? Now let me show you the mechanism. This is what happens. Here you need to be focused because it's a very complex process that goes on, and any divergence in attention can cause misunderstanding. So here we get this molecule, plus we add hydrazine to it, NH2 bonded to NH2. Now in that process we have a lone pair on nitrogen which will be attacking this carbon, right? And this bond pair will be converted into the lone pair of oxygen, right? So what we will be getting is something like this. We'll be getting something like this. Here a single bonded oxygen will be there, and a negative charge on oxygen will develop, and also this nitrogen, which has H on upper side and H on lower side, and this NH2, fine. Now you can see this hydrogen has developed a positive charge. Let me try to the different color. This hydrogen has developed a positive charge because it just donated its lone pair of electrons, right? Now what happens in this mechanism is that this lone pair is converted into bond pair, and this bond gets broken. It gets converted to, this bond pair is given to this nitrogen. It already has a lone pair of electron. This nitrogen, you see, it has a positive charge, so it will be withdrawing these two electrons from the bond, and H positive getting released from this H positive, right? Now this nitrogen will be giving its lone pair to this hydrogen, which will give us something like this. Here oxygen is already present, which you need to know. So what we get is something like this. Let me draw it a big benzene ring. Right, here you can see oxygen double bond is restored. You can see it here. Fine. After that, here oxygen is also present. So what we have got here now is NH from the hydrazine and NH2, and this bond has been broken. This bond has been broken, right? So what we get is NHR. Fine. This is the product from this step. Now what happens is this lone pair on this nitrogen acts on this carbon, and this bond pair gets converted into the lone pair. What we'll be getting? We'll be getting something like this. Let me draw it. All right. Here oxygen. Here we have NH. Below this we have this NH and H. Since it has donated its lone pair, so it will be developing a positive charge. On the lower side we have something like this, right? Here we have O negative, and here we have this oxygen, this NH, and the lone pair on this nitrogen and R, right? So this is what we have got till now. Now after this, what will happen is that this again the same process will be happening, right? Here is a single bond, right? You should know that. So this lone pair of electron will get converted into a bond pair. This bond will be broken, it will be given to this. Since this nitrogen has a positive charge, it will be taking this lone pair into and converting it into its bond. This will be taking its bond pair and converting it into its lone pair, and this nitrogen will be donating its lone pair of electrons to this H positive, and here we have got it. Here you see we have got the NH. Let me just draw it. All right, oxygen. This molecule is called 1,4-dione. So here you can see that the third step of the reaction of this synthesis is very complex. You need to make sure that you watch it again and again so that you get to understand what the steps are and how it occurs, right? Plus, what we have got, which we forgot to write, that's our main product, RNH2. Now, in this step, you need to focus that in this ammonia, this nitrogen, it is not from hydrazine, it is from the phthalimide, right? It is from phthalimide. You need to note that. It is from phthalimide. So if the reaction mechanism, if you get a question in the form of tracers, that is we get N14 and N15 isotopes with phthalimide and hydrazine. So we should be able to understand that if N14 is with phthalimide, this nitrogen will be N14. And if N15 is with phthalimide, then this nitrogen will be N15. You should be able to answer those questions, right? So this was the mechanism of the reaction. Hope you understand that. We have got 3 steps in this process. The first step was that we added base to phthalimide, which yielded us phthalimide ion. In the second step, to the phthalimide ion, we added alkyl halide, which yielded us a molecule something like this. In the third step, we added hydrazine in order to break these two bonds, and provide us with 1,4-dione and RNH2. Now in this synthesis, you must be seeing that there is no way in which R2 and H can be synthesized or R3 and can be synthesized, right? So from the Gabriel Phthalimide synthesis, only primary amines are formed and no secondary and tertiary amines can never be formed. These can never be formed, right? Hope you understand. Make sure to subscribe to the channel Chemistry Crux in order to get more videos like this.